All right. Well, looks like we got a pretty good house joining in already. So we want to welcome everybody to today's webinar on learning about the new computer lineups that Dell has procured to help you utilize SOLIDWORKS more efficiently. Just as some housekeeping rules, everybody is muted, but if you have any questions that pop up at any time when we're doing this webinar, please feel free to use the questions section and we'll start addressing those either throughout the webinar or at the end of it as well. And also make sure that you are in attendance to the full end of this webinar as well, because we are going to be doing a raffle giveaway for a Dell monitor. And you do have to be in attendance in order to accept or to win the raffle as well. So please make sure that you stay on with that. And we'll go ahead and get this started. All right. So yeah, again, thanks everybody for joining this webinar on a product review for the newest lineup of Dell workstations for SOLIDWORKS. I am your presenter, Charn, and I also have on the phone with me Scott and Don from Dell and NVIDIA, respectively. I've been using SOLIDWORKS since 2005 when I started my undergraduate, and have been working with GoEngineer for 9 years now, which is, can't believe it's been 9 years too. But been pretty glad to be part of this presentation as well. Scott, if you want to introduce yourself a little bit.
Yeah, hello everybody. My name is Scott Hamilton. I'm an industry strategist for the Dell Performance PC group, which includes both precision workstations and rugged products. And like Charn, I was an engineering major, aerospace engineering, and I worked at an aircraft company, a couple of them actually, and also was in the software industry for a while before I came over to the hardware industry working for Dell about 13 years ago.
Hey everybody, my name is Don Breda and I manage NVIDIA's strategic partnership with several ISVs in the manufacturing space, including SOLIDWORKS. My professional background is I have an engineering background in as far as education goes, and worked as a civil engineer for a long time, and then worked in the CAD business for quite a long time. Spent about 14 years at one of the big three CAD companies. Happy to be here.
Nice. Well, yeah. So just to give you a quick overview, everybody, if you don't know who we are, this is GoEngineer. We are one of the largest resellers of SOLIDWORKS, and we actually offer several different products that you can use from a CAD space. These include all of the Dassault product line for SOLIDWORKS and CATIA and the Simulia lineup as well as CamWorks and Strategist for 3D printers and Creaform for scanners and stuff like that. We are nationwide now, especially with our acquisition of the CATI team. So if anybody is coming from that reseller, we have now merged together as of January of this year. So we're proud to be across all 50 states in the United States. We are expanded into Canada as well in regards to adding in Strategist capabilities to our friends up into the north as well. Now for the Strategist lineup of things, we offer everything from their PolyJet lineup to their FDM lineup to their newest technologies that they're continually bringing out to better help the additive manufacturing side of things too. When it comes to metal printing, we work with Velo 3D and Exact Metal. So depending upon your needs, we do have quite a bit of solutions for you on the 3D printing side as well. We also partner with Arctic 3D and Creaform for scanning capabilities. So if you are in need of any scanning services or even looking to purchase your own scanners, feel free to reach out to us and we'll be more than happy to help guide you on the best technique for this as well. Now, along with that, we are the world's leading in training for SOLIDWORKS. So we have several different options when it comes to training. We have classroom training at one of our local facilities, as well as online training. And online training is encompassed either in a live instructor-led training, or we also offer self-paced training as well. And these will just help you in making sure that you're prepped for any certifications that we may offer with your SOLIDWORKS subscription and stuff like that. So we're here to help you guys make sure that you succeed in excelling in SOLIDWORKS and all of the other products that we offer and sell too. Now, the main reason why you're here is you're trying to figure out what is going on with hardware related things inside of SOLIDWORKS. You know, it's a big question that's always been asked from when CAD first started off back in the late 80s and continuing to this day. We're always needing to have new hardware, and it'll be good to understand, you know, what is the utilization of SOLIDWORKS when it comes to that hardware. So when you're 3D modeling, whether it's parts or your assemblies, you want to have like a balanced approach to this. A lot of your utilization from the modeling side is going to be on your GPU and your CPU. Now, when it comes to a CPU, you know, things that you have to consider is that modeling for parts and assemblies are single core, single threaded operations. So keep that in mind when you're looking at, you know, at the latest GPUs. You want to go for those higher clock speed core counts, because that'll guarantee that you get the highest maximum speed during the modeling process. And again, SOLIDWORKS on the modeling side will be single core, single threaded. And this is definitely prevalent during the opening and saving and closing of the documents as well. And then to display the geometry, that's where the GPU comes into play too. Just note that GPUs are certified for workstation class GPUs, which we'll talk about more in this webinar as well. And it's limited to a single GPU. So having more than one GPU on the modeling side isn't going to be beneficial to your you know, proficiency and efficiency inside of the software as well. Then you can consider adding in RAM, and you know, an SSD is not uncommon these days. And you can do traditional SSDs or the more modern NVMe style as well for it. Now, when it comes to the simulation side of things, this is where we have to change our perspective of what we're actually going to be focusing on from a hardware perspective. For all of our simulation products, whether it's desktop simulations for SOLIDWORKS simulation, flow simulation, or plastics, it is basically a multi-core, multi-threaded capability with this. And so you'll want to focus on more cores that you're going to be looking at when you're trying to analyze these types of add-ins that we offer to the SOLIDWORKS product line. Just keep in mind, there is a sweet spot within there that's going to be around 10 to 12 cores. Anything beyond that, you're probably getting a diminishing return off of there. But we are able to maximize multiple cores when it comes to the simulation side. Along with that, because of the calculations and stuff like that, you'll want to focus on more RAM, because SOLIDWORKS does store a lot of information in the RAM while you're using the software, and that can help retain that information. And more importantly, when we talk about RAM, we talk about ECC memory, or error correcting code memory. So those are more of the workstation class levels, and it just guarantees that you don't have as many issues in regards to SOLIDWORKS crashing. The ECC memory can help prevent crashing through that whole process. After that, you can then get a lower end GPU when you're doing simulation, because you're only using the GPU to display the results, not actually do the calculations. And then just like before, you can work off of an SSD for that. Now, if you're doing things like rendering inside of SOLIDWORKS Visualize, this is where you're going to change your concept of you want to focus as much as possible on that GPU, because it can maximize all of the types of cores, especially on an NVIDIA GPU, where you have your tensor cores and your ray tracing cores, and things like that, it's able to maximize that. And even better with SOLIDWORKS Visualize, if you have multiple GPUs on your system, it can maximize all of the GPUs on your local system as well when doing that. I've done webinars in the past too that focus on the performance versus GPU and CPU. So if you haven't checked that out, I would tell you go to our website, type in visualize hardware utilization, and you'll see a nice comparison webinar that we've done to showcase why the GPU is going to be king when it comes to visualize itself. Okay, so that kind of gives you a good idea on the utilization that we have here for SOLIDWORKS and in regards to the hardware. So I'm actually going to pass it over to Scott, who's going to expand more on the solutions that Dell offers.
All right, thank you, Charn. Yeah, I'll talk a little bit in a little bit more in detail about the workloads on a workstation when you use SOLIDWORKS. And there's really two different types of workloads that we see, and that we call that interactive and computational workloads. And to distinguish between the two, interactive is when you're doing your modeling work, or visualization is another good example of that. And what typically defines an interactive workload is when you're interacting with the system. And there are, I kind of call it's a peaky workload. In other words, there's periods of time when you're using and pushing the system to its limits, and then there's other times where it's essentially idle because you're thinking about your next step. For example, when you're modeling a part, you're going to start designing some features and adding fillets and different things, holes in the part. But in between doing those operations, you're thinking about your next step. So there's not really much happening on your workstation at that point. In the typical workload we see here is, if we look at this radar diagram, you can see it pushes the system in certain areas like the CPU turbo frequency, GPU rendering performance because you're spinning your model around, memory speed, and also your storage sequential read and write. As you're going to periodically save your model, or you might have autosave turned on, so it will save it automatically for you. Those are kind of the areas of the system that are being exercised when you're doing interactive work. Now, computational work is very different, and this tends to be push the system in a different way. And what areas of the application are more computational? Obviously, that's visualization, rendering, simulation analysis, plastics. Those type of features within SOLIDWORKS will actually fall into that computational workload. And there are more important things there. For example, your CPU core count, because that's highly multi-threaded. And as Charn mentioned, 8 to 12 cores is a good target spot for CPU core count. And then, of course, if you're doing visualization using SOLIDWORKS Visualize, then the CPU cores can really help there. And of course, the amount of GPU cores, and then the amount of memory on the GPU is very important as well. Also, the system memory is important because as you use more and more cores, you'll want to have, around 4 gigabytes of memory per core to be available for solving those simulation and analysis problems. And that's very important because if you can get the whole data set into the CPU or the GPU memory, depending on what you're doing, then you don't run into this operation called swapping, where the system has to temporarily put some memory on the disk so it can do something, and that will dramatically reduce the performance, because obviously writing things to a disk, even an SSD, is much slower than keeping it in memory. So those are the kind of different workloads that you'll see when you're using SOLIDWORKS, and you can see, looking at the overlay diagrams there, that it exercises the system quite differently. So it's really important to understand what you're doing on the system and get the system that's going to give you the best performance. And that really brings me to the next point about what things do we need to consider when we're choosing or configuring a system. And we just talked about it depends on the workflow and the application, right? It depends on what you're doing. But also you want to consider getting a balanced system. So if you're doing operations that are both interactive and computational, then you want to build a balanced system so that you get the best of both worlds. You don't want to just focus on one area to the detriment of another. So always consider not only the things you're doing in SolidWorks, but you may be using other applications outside of SolidWorks. Like, I know a couple of really popular ones are MathWorks, for example. Or sometimes if you're doing more advanced simulation work, a lot of customers I talk to are using ANSYS products to do, very sophisticated simulation analysis, and that has slightly different requirements. So you really want to look at, your entire workflow and make sure you're getting a balanced system. Also, concurrency is another important factor. You may want to run some SolidWorks simulations in the background while you're also doing design work at the same time, right? And so you kind of have to consider, okay, maybe I want to have 8 cores for simulation, but I want to have 3 or 4 cores for doing the design work at the same time. So now you're looking at 12 cores minimum, probably more, because you also have to remember that anytime you're using your system, there's hundreds, if not thousands, of processes running in the background on your system. So you want to kind of leave a couple of cores to do those background processes as well. And then also consider what your future needs are and future expandability. So we all know that our models aren't getting less complex these days. They're only getting more and more complex. And vendors like SolidWorks are always adding more features, and they're taking advantage of the hardware in much better ways in the future. So think about, not only what are you going to be doing today, but what are you going to be doing a year, 2 or 3 years down the road, because you're probably going to keep your workstation for a few years anyways. And then think about expandability, right? Like, for example, do I want to add a second graphics card to my tower system in the future so I can really do a lot of high-speed visualized rendering with 1 or more GPUs, right? And we do offer some systems that will actually take 4 double-wide GPUs, so you can have a really powerful rendering system as an example. Or you might think about, well, right now I only need 32 gigs of RAM, but in the future maybe I want to expand that to more 64, 128 gigs of RAM. So think about those type of things when you configure your system. So I have some kind of high-level recommendations, and Charn touched on a lot of this already. So I'll kind of hit the highlights on these slides. You guys can obviously download these after the webinar. They'll be available. You'll get an email. So I'll hit the highlights, and you can always go back and reference this. But for interactive work, for standard use of SolidWorks doing design work, we really care about clock speed and essentially turbo clock speed on the processor. And SolidWorks recommends at least 3 gigahertz or better. Our modern systems now offer up to like 5.8 gigahertz of turbo clock speed. So they're quite powerful when it comes to that. And you don't need a lot of cores. 4 cores is fine for just SolidWorks. Remember, you're going to want a couple extra cores for those background processes. But our minimum system these days is 8 cores or more. So you're going to have no problem, finding a system that's going to supply 4 cores. If you're doing simulation work, of course, the clock speed is important, but what's more important are the number of cores. So as Charn mentioned, 8 to 12 cores that you want to look at there. And if you're doing even, want to run multiple simultaneous simulations or running some other applications, like I mentioned before, ANSYS or something, you may want to go even above 12 cores. And then for visualize, it's not very CPU dependent. We'll talk about, as Charn mentioned, the GPU is really where you get the power in visualize. So from a RAM perspective, basically, I recommend starting at 32 gigs of RAM and then going up from there depending on what you're doing. Now, some users that are doing very small part design, or maybe a manager that just needs to load models for approval processes, you could get away with 16, but not. I would generally start at 32 gigs for most stuff, and then of course increase RAM for simulation work accordingly. As you add more cores, you would want to go up to 64 or maybe even more. And then for storage, I always recommend an SSD. SSDs are so much faster than spinning drives. And actually today it's really hard to find spinning drives because SSDs have come down dramatically in price and the performance is just tremendous. And you have to kind of decide how much you want as far as capacity. And it's really based on, what you're doing here. Simulation, sometimes your models are a bit bigger. Certainly for visualize, if you're going to do a lot of rendering, those renderings will take up a lot of space, and certainly if you're doing animations as well. My recommendation also is just consider where you're going to store your data, right? A lot of people now are using separate centralized storage and the SolidWorks PLM system to manage the assets. So if you're storing a lot of your assets on a centralized server, then you can go to the low end on the local storage, because you're going to be storing a lot of your assets on a centralized SAN or SAS or something like that. And then on the GPU side, for simulation and just standard design work, really what we would call a mid-range graphics and A2000, A3000 class graphics is a good solution for most design and simulation work. Visualize, however, you're going to want to look at a bigger GPU because that's going to give you all of those extra ray tracing RTX cores. Don will talk about that some more. And the higher you go up in the stack, you'll get more cores to utilize for that rendering. And Don has some really great slide he'll share with you showing the performance differences you get with the different class of cards. And then also, as Charn mentioned, you can actually use multiple graphics cards for the visualized rendering. And again, we have systems, our tower systems, that can utilize 1, 2, or even up to 4 graphics cards in one system. So you can really have a SolidWorks visualized rendering, powerhouse or supercomputer for rendering, if you like. All right, with that, I'd like to hand it over to Don to talk about the NVIDIA GPU solutions.
Thanks, Scott. So as I mentioned earlier, my name is Don Breda. I manage NVIDIA's strategic partnership with SolidWorks. Let's see, can I forward slides? No. There we go. So as you probably already know, your GPU choice is very important when you run SolidWorks. It makes a huge difference in the responsiveness of the software and determines how smoothly really that you can spin, pan, zoom, kind of rotate, basically the manipulation of your model. A good card is particularly important when dealing with more complex models and can really improve your day-to-day productivity and really give you a better positive experience with SolidWorks. You're not waiting. The model's not jerking around as it's moving. So why are NVIDIA GPUs so much better for SolidWorks workflows? Well, so the NVIDIA RTX platform is really the most advanced visual computing platform that's available today. Over the past couple of years, NVIDIA has expanded the availability of the RTX technology for professional customers, from desktops to laptops to the data center and the cloud and embedded devices. So this platform enables customers to take advantage of cutting-edge technology such as GPU-accelerated rendering, simulation, data science, and compute. The RTX platform supports virtualization of powerful virtual workstations, along with the ability to provide compelling extended reality experiences in VR and AR. So the GPUs become essential, really the GPUs become the essential engine that drives all of these workloads. Each new architecture of our GPU has improved on performance, efficiency, and capabilities to drive more advanced workflows and raise the bar for graphics and computing. Some of you may remember or may be familiar with the Turing architecture that we released several years ago. This was a huge leap forward for computer graphics. Turing introduced the NVIDIA RTX technology for the first time and brought real-time ray tracing powered by the NVIDIA RT cores, Charn had mentioned that earlier today, and AI acceleration powered by the tensor cores to professionals. It opens a whole new world of photoreal graphics and AI-enhanced productivity. So we've continued to advance our GPU technology with new leaps forward in our Ampere and our Ada Lovelace architectures. We took the advancements that we made with Turing and we more than doubled the throughput of our RTX technology. As a result, performance has been amplified to a new level, providing greater productivity and creative freedom than ever. So let's look at a few of the key technologies that make this possible. So as I mentioned, NVIDIA fundamentally changed computer graphics with the introduction of that RTX technology in 2018. We brought the power of real-time ray tracing, accelerated artificial intelligence, and advanced graphics and computing technology to the desktop for the first time. And then we next introduced the second generation RTX technology with NVIDIA Ampere, and the third generation of RTX with the Ada Lovelace architecture. And Ampere and Ada Lovelace provide basically second and third generation RT cores to deliver up to twice the throughput of the previous generation, that's gen to gen. Hardware giving you even more speed to interact and design with ray trace scenes and explore even larger scenes. Third and fourth generation tensor cores to accelerate AI-based tasks. And that's whether you're working with AI features in creative applications like AI denoising in Visualize, or deep learning super sampling that you may run into in the gaming industry or in other applications, and doing more traditional deep learning training and inferencing work. And then up to 2 times gen over gen single precision compute performance with the latest generation of streaming multiprocessor or CUDA cores. You've probably heard about our programming language, CUDA, that does general programming on GPUs. That's just what we call our simultaneous multiprocessor cores, is CUDA cores, because we wrote CUDA for it. So what do these different GPU processing cores mean to you as you use SOLIDWORKS? It basically means that you can work on large assemblies with full fidelity graphics without interruption and get your photorealistic images and animations faster than ever before. So first there are the RT cores. Is this animation running or do I have to kick it off? There we go. So first there are the RT cores. Basically, the RT cores help to accelerate the math that's needed to trace the virtual rays of light through a scene very efficiently, leaving the CUDA cores to focus on shader calculations or the color of those generated pixels. So they make ray tracing really, really fast. Then there are the tensor cores, which accelerate artificial intelligence-based tasks like AI denoising used in SOLIDWORKS Visualize. When you turn on AI denoising, Visualize will complete about 10% of the brute force ray tracing calculations needed to fully ray trace the scene. And then AI denoising will instantly finish the job and provide you with an incredibly close approximation to what the final fully converged image would look like. This allows you to iterate on your design based on your ray traced results. SOLIDWORKS Visualize was actually one of the first product design focused visualization tools to harness the power of the GPU. And it's also one of the first to add support for NVIDIA RTX. It supports multiple GPUs, as everybody has said earlier, and SOLIDWORKS Visualize is built upon NVIDIA iRay technology. And iRay takes full advantage, because it's our technology, takes full advantage of our streaming multiprocessor NVIDIA CUDA cores and is tuned to get the best performance with NVIDIA RTX GPUs and their optimized drivers. And actually in SOLIDWORKS Visualize 2023, added the ability to render in Dassault Systèmes Stellar rendering engine, which is built upon NVIDIA optics. So you might ask, why does NVIDIA have 2 different ways of building a ray traced application? Basically, iRay is the higher level SDK and optics is a lower level API. Iray allows you to build a ray tracing application more quickly, and optics allows you more direct control as you build your ray tracing application. Don't worry, either way, both are tuned so that you'll get the best performance with NVIDIA RTX GPUs. Oh, trying to get this slide forward. There we go. So what about SOLIDWORKS? SOLIDWORKS CAD takes full advantage of NVIDIA RTX to speed up the product design workflows that you do in it. So SOLIDWORKS itself benefits from the large memory and high performance of NVIDIA RTX GPUs and delivers a fluid CAD experience, even with the largest models and assemblies. We worked with SOLIDWORKS over the past several years to help them optimize their graphics pipeline to push the majority of the visualization work over to the GPU. This gives you smoother spin pan zoom operations at full model fidelity and allows the CPU to do more of the work that a CPU needs to do in a CAD application, like regenerating models. There's no more need to reduce the level of detail in your largest assemblies when you're manipulating them. And we continue to work with SOLIDWORKS development to further optimize both SOLIDWORKS itself and our NVIDIA RTX professional graphics drivers to give you the best and most performant user experience with SOLIDWORKS on NVIDIA RTX professional GPUs. NVIDIA RTX even provides you the performance needed to dynamically review SOLIDWORKS models in VR with eDrawings Pro VR, for example. And Visualize lets you take that review of your CAD models a step further, rendering them incredibly quickly with photorealistic quality thanks to the ray tracing and AI denoising technology. So you can see on this screen, I've got a couple of performance charts showing the performance changes as you go up the stack in NVIDIA GPUs. One of them is for desktop and relies on a spec benchmark called ViewPerf. You can go to spec.org. If you want to see these benchmarks, they're publicly available. You can download one and try it on your own machine. And the laptop uses a SOLIDWORKS Visualize benchmark that we've worked together with SOLIDWORKS to build. So you can see how much faster Visualize gets as you go up the product stack. So that's pretty much it. To recap, whether you're looking into an RTX-powered laptop or desktop or virtual workstation, they're all great choices to take your work to the next level. The NVIDIA Ampere and Ada Lovelace architecture at the heart of these solutions, we're offering our most advanced GPUs for professionals yet. You can learn more about our NVIDIA RTX solutions on our website here, or go to Dell.com and configure a great Dell system with NVIDIA accelerated technology and do great SOLIDWORKS work. Handing it back to you, Scott.
Thank you, Don. Great job. All right, guys, I just want to give you a quick overview of the Dell Precision product portfolio so you can kind of understand what systems you want to look at. And we have some more detailed recommendations coming up, of course. But at a high level, we offer 3 different series of platforms, and you can see also 3 different form factors. So we have mobile, tower, and rack systems. And then we break that down into 3000, 5000, and 7000 series platforms. And they're all targeted at a little bit different use cases. You know, we look back at the interactive and computational workloads and various, levels of expandability. What you're going to find is as you go from 3 to 5 to 7, you're going to get more power, more expandability, more configurability as you move up the product stack. And then, of course, we all know, because everybody's working in a hybrid environment these days, it seems like, mobile systems have become very, very important. So you can work from anywhere, whether that's in the office, home, or on the road. Of course, we still offer our traditional tower-based systems where you need really extreme performance, especially when you get up into the 5,000 and 7,000 products in this area. And then kind of a unique offering is our rack-based workstations. These allow you to put the system in a machine room or a data center, so it removes the heat, the noise, and the space out of the working environment. You can connect to those systems remotely, and it works just like the system was sitting at your desk. But again, you don't have the system taking up space at your desk or creating heat or noise. So it's a nice solution if you're looking for some kind of remote solution as well. So depending on what you're doing in SOLIDWORKS, again, will depend on what kind of products you want to look at. But at a high level, our 3000 series, what we could consider entry-level workstations. Now, these are much more powerful than your typical, business computer, of course. So if you're looking at doing kind of on the low end, then a 3000 series product, or we consider our 5000 series our mainstream. So these systems are going to be really good for a combination of doing interactive and computational workloads. And then the 7000 series are the maximum performance. So when you're doing lots of computational work, whether that's simulation analysis or rendering, then the 7000 or some of the 5000 will be very good for that computational workload. So let's just take a look at a couple of recommendations. And again, this presentation will be available for you guys to download because I'm sure you're not going to memorize all this stuff. But again, entry level, I would recommend a 3581 system. It's got a nice balance of high clock speed. You can see up to 5 gigahertz here. A mid to lower end range graphics, 16 gigs of RAM, and a 512 gigabyte hard SSD. So that's a good entry level system. I would say for most SOLIDWORKS users for mobile, I would recommend the 5680. You can see we're bumping up the RAM to 32 gigs of RAM, a little bit higher end GPU, so you can do a good balance of larger modeling and also some rendering if you like with that system. And this has a much better higher resolution display and a little bit larger SSD of 1 terabyte. And then if you're looking at really doing a lot of simulation, whether that's fluids or structural or rendering, plastics as well, then a higher end CPU, a much higher end GPU, mainly that's for the rendering part. If you're just focusing on the simulation and not doing any rendering, then you could drop that down to probably a 3500 or a 4000 level GPU. And then again, there's some more, a little bit larger SSD because those models tend to be much bigger. So those would be my basic recommendations for SOLIDWORKS on the mobile side. And then on the tower side, of course, similar recommendations. This is our 3460 small form factor. This is a really nice machine for entry-level SOLIDWORKS work where it's a nice small unit that you can put, on your desk or underneath your desk. It doesn't take up much space. Fairly configurable, again with a pretty high clock speed CPU because probably most of the work you're going to be doing is in that interactive realm. And then again, if you want a little bit more powerful system, this 3660 actually is a really great system because not only is it fairly expandable from a GPU, a storage, and a memory perspective, it's a great all-around system for using SOLIDWORKS. So if you could even put up to a 6000 class GPU in here, it's actually quite a good system for doing rendering as well. But then if you want to kind of take that to the next level, then I'd recommend the 5860, which is our bigger tower. You can get some more cores. Actually, this will go up to 24 cores. I'm recommending 12 for a mainstream one, but if you're going to do more and more simulation analysis or talk about that concurrency, we're going to try to do multiple things at once, then I would recommend this system and maybe go up to 16 or more cores there. And then, of course, a higher end GPU for that SOLIDWORKS visualized rendering, and then more memory for more simulation work, and then a larger storage device of 2 terabytes. So these are kind of general recommendations. You guys can always tweak them as you see fit based on your exact needs. So speaking of more recommendations, I want to remind everybody that we have this GoEngineer Dell Expert Network page. Here's the URL right here, http://www.dell.com/GoEngineer. We have additional recommendations up there, and we're actually updating these in very near future because all of those new workstations I talked about were just recently launched. So we're updating the recommendations there. If you want the latest and greatest, there's a contact link on here. One of our experts can help you configure the latest and greatest workstation. And we also offer, through this program with GoEngineer, a 10% discount. So when you go to the configurator, you can click the links down here. Those are, I know it's hard to read, but it says customize and buy. You can click those links and you can purchase those, and then you can apply your special discount coupon that you can get from clicking this link here. And that will give you an additional 10% discount. And you'll find that a lot of these recommendations here are already discounted 25 or 30%. So that 10% will add on top of that as well. So you can get some pretty great deals if you go through the Dell Expert Network page that you see here. And these have all been co-developed with Dell and the GoEngineer experts like Charn, because they really know a lot about what will give you the best performance. All right. I also want to just mention quickly, we do have this Advanced Product Design Resource Center. This is a cooperation of Dell, NVIDIA, and digital engineering that you may be familiar with. And we have created this resource center that has all kinds of information related to the engineering and manufacturing industry. It's not even specific to SolidWorks. We do have a special SolidWorks curated version of that, but there's articles about all kinds of trends and information related to engineering and manufacturing that you might find interesting. So you can go to this link and learn more about it. There's lots of articles here, like we have this accelerating advances in CAE, for example, or there's an update on the latest graphics technologies event that was the GTC event hosted by NVIDIA. There's hundreds of articles that you can reference there. So it's a really great resource. So I encourage you to look at that. Here are some additional links. Again, you'll have access to this presentation that we offer. We have the Dell Precision Optimizer, hardware certifications. Just a reminder, we work really closely with the SolidWorks team. All of the Dell Precision workstations are certified to run SolidWorks software. We have our Workstation Advisor tool, which will give you additional recommendations, as well as our Engineering and Manufacturing Industry Guide. This is an interactive guide that we publish that you can reference for more details on that. And then I talked about our Advanced Product Design Resource Center right there. So all kinds of great information for you guys to reference. So with that, I'd like to hand it back to Charn because we want to open it for Q&A, and also we've got our monitor raffle coming up.
Yeah, awesome. Thanks a lot, Scott and Don. Great info on this. There have been some questions that have popped up already, so we're going to start addressing those. Again, if you have any questions that you want to address, feel free to bring them up right now in the questions section, and we'll be more than happy to answer them as well. Okay. So first question we have going on is in regards to the Quadro lineup of GPUs. The Quadro lineup is the previously known architecture, or not architecture, but naming scheme that was used for the GPUs. It was starting in 2022 when the Ampere lineup was being officially supported with SolidWorks. Actually, I believe it was 2021. Service Pack 3 is when they started actually supporting those. So your Quadro cards will still work. And if you're looking at like older ones, like if you're still using like Kepler-based CPUs, those aren't going to be supported in the modern day ones. And you're probably looking at Maxwell being phased out shortly for it. And then Pascal would probably be the oldest that I would use in regards to it.
Yeah,
for that,
Quadro
Scott.
is really a brand change from NVIDIA. So our professional GPUs used to be called Quadro. We have a similar brand change on the server side. Our previous data center GPUs were called Tesla. Both the Quadro and the Tesla monikers are being retired, but we're still continuing in spirit, basically, with the NVIDIA RTX line. You can consider that the new NVIDIA Quadro line, and the NVIDIA data center GPU line replacing the NVIDIA Tesla line.
And also too, Don, with the new GPUs, at least with the Ampere lineup, it's the RTX and then it has an A in front of the number scheme for the professional lineup.
Yeah, there's two ways that so in addition to getting rid of Quadro and changing it, so you can effectively replace NVIDIA Quadro with NVIDIA RTX. And then the models in the Ampere generation are preceded by an A. That changes with Ada, and so I'm being told will continue to go forward in this way, in that it will be NVIDIA RTX 6000, for example, and then the name of the generation. So the first one of these is the NVIDIA RTX 6000 Ada, or Ada Loveless. And everything going forward should be like that. So NVIDIA RTX 5000 Ada, and then whatever the subsequent generation is, it'll be NVIDIA 6000, NVIDIA RTX 6000, whatever the next generation is. They're telling us that that will continue going forward. So hopefully the branding stops changing with every generation with that.
Okay, sounds great. Hopefully that answered your question, Sean, on that.
And Charn, just a quick mention, this might help solidify things a little bit. If you look at the recommendations for the mobile products, you'll see that many of these have Ada on them. So Dell has launched the new Ada graphics on their mobile systems, and the Ada cards are going to start coming out on towers very soon. So the RTX 6000 Ada that Don mentioned will start becoming available on some of these towers in the very near future, and we'll see more cards coming, in the future as NVIDIA releases those products.
Right.
Okay, awesome.
I see a next
Scott,
question, Charn. Is the RTX A4000 Ampere based? Yes, it is.
Yeah. Scott, do you think you can expand on Peter's question about the overlap between the 3000 series and the 5000 in regards to like selection options that they have, and what benefits do like the 5000 have over the 3000 series?
Yeah, on the systems in general?
Yeah, his question is like he's noticed like there's been overlapping of options that you have available between like the 3000 and the 5000 series.
Yeah, and that's a typical thing. And even between the 5000 and the 7000, you'll see if you look at each of the components, whether it's a CPU, a GPU, or memory, there's kind of an overlap. And if we go, let me go back to that slide for a minute, where we're looking at the whole family, right? There will be an overlap. So for example, components are offered on multiple systems, and that's to give you guys flexibility in configuring the systems. But what you want to consider here is you will be able to go higher end components as you go up higher in the product line. So the 7000 series will have the highest end CPU available, the highest end GPU available, and more storage flexibility, right? Expandability. And the other thing that you have to remember, just as an example, like you could configure a 5000 series product actually with, for example, a 5000 Ada graphics card, and you can configure a 7780 with that same graphics card, okay? But in reality, you will get better performance on the 7000 system than on the 5000 with the same graphics card. Why is that? Because the 7000 series is bigger, it has a better cooling solution, so we can run the components like the GPU at a higher speed and generate more heat and cool that more effectively. So it's kind of an idea of giving you as much configurability as possible, and also as much performance as you need. So, you know, as you look at it, a 3000, 5000, or 7000 series product could meet any of your needs. But, you know, based on what you're doing, and if you're doing a lot of computational work, I highly recommend you go to the 7000 series on the mobiles, or the 5000 and 7000 on the towers. Hopefully that answers your question.
Yeah, I think that was a good explanation on. Next question was in regards to like 12 cores based and diminishing returns off of it. So again, from a modeling perspective, designing your parts and your assemblies are more GPU focused. So you're really only going to look for those running as single core, single threaded operations. And that's why the higher clock speeds would benefit you from a modeling side of things. In regards to simulation, based upon, you know, the studies that we've done with various different customers and, you know, simulations that we've done here at GoEngineer, we've seen that the sweet spots for your best bang for your buck will range anywhere between 8 cores and 12 cores. Once you start going beyond 12 cores, then what you're noticing is that you're spending a lot more money per core, and the reduction in the simulation time is not being reduced linearly for that. So that's usually the range that we recommend to our customers to get, just to make sure that you're not just wasting a lot of money on these, you know, 64 core and 128 core CPUs off of there from a simulation side of things. If you go beyond the 12 core, the only benefit is like what Scott was mentioning is that you can do more parallel things by using other softwares, you know, allocating information just for Outlook and all that stuff too. So that's where it would be beneficial. You would have to start looking at setting up core affinities within Windows to make sure you allocate SOLIDWORKS only uses 12 max, and then everything else can use the rest of the cores for that.
Yeah, that's a great answer, Charn. And one of the interesting things is about the new Intel hybrid core architecture is it does some of that work for you. It will look at what are the most demanding workloads and put those on the bigger, better cores automatically. That's another reason I would also recommend moving to Windows 11, because the hybrid core architecture is really optimized for Windows 11.
Just keep in mind, if anyone does upgrade to Windows 11, that I believe it was SOLIDWORKS 2022 around Service Pack 2 or 3 when it was officially supported. So you may have some graphical issues if you use an older version, and that's just something to be aware of as well.
Yeah, good point.
What would you recommend when working with large surface modeling for automotive? So again, when it comes to dealing with like larger complex designs and more components, there's a lot of things to consider to help that. Again, because that's a modeling perspective, your clock speed on your core count is going to be the things to focus on. And then your GPUs, you can probably look at the mid to high tier GPUs. So around, say, like an RTX A4000, or when the, you know, the Ada 4000 comes out, that would be a sweet spot line. Going beyond that, it really just depends upon what type of issues you're seeing and the number of models, and understanding different techniques for modeling those larger assemblies. Danielle, if you want to discuss that a little bit more, reach out to us and we can have a further discussion to help you determine what would be the best route for it. Are release drivers for workstation class GPUs tested for reliability with a standard set of programs? Yes, basically, you know, Don, you guys at NVIDIA are always validating.
Yeah, I can answer that, Charn. So the question is, are driver releases for workstation class GPUs tested for reliability with a standard set of programs, SolidWorks, AutoCAD, ANSYS, et cetera, before release? Yeah, the professional drivers, the NVIDIA RTX drivers get run through a series of regression tests based on benchmarks that we've been given by our partner ISVs. So they get run through anytime that there's a new build of a driver. So hopefully we catch all kinds of issues that we have set up to catch, and of course sometimes some get through, and then we work with the ISVs to build those further tests into future regression testing.
And actually, in addition to that, not only does the graphics get tested, but the entire workstation gets tested. At Dell, we have a certification program, and we've been working with the SolidWorks team for 15 or more years now. And so we send many of these workstations to the SolidWorks certification team, and they're tested specifically with the, different graphics cards, different configurations. And those are all listed on the SolidWorks website, or there's on Dell.com, there's a listing as well of all the certified workstations for SolidWorks. And pretty much every time we release new products, all of those products get certified. Now, sometimes it takes a little time before those are all processed, but pretty much every product we launch gets certified for SolidWorks.
I also saw there was a question on here asking to explain the difference between the Maxwell M cards, Pascal P cards, so people might know the difference, unquote. Those are just different generations of NVIDIA GPUs. The Maxwells are the oldest on there. That would be like a NVIDIA Quadro M4000 or something like that, 4000 class GPU of the Maxwell architecture generation. And then Pascal was the generation after Maxwell, so you'll see things with P preceding it. Like I said, the marketing names have changed since then, and really the difference between those architectures is that they fit more simultaneous multiprocessors on the GPU die, so you have more cores to do your work as the generations go forward. They build smaller cores and more of them on a die. So basically GPUs become faster over time, and then some features are added with Turing, which came after Pascal, to add things like RT cores and tensor cores that can accelerate other forms of other workflows. Hopefully that answers that question.
Yeah, and if you're thinking about upgrading SolidWorks in the future too, there is actually information in the help that'll tell you what the supported architecture is on the GPUs. But if you forget about that, just reach out to us at GoEngineer, and we'll be more than happy to let you know whether or not it's going to be supported or not, especially from like a visualized side of things as well. So that may help drive you upgrading your hardware in the future too.
Hey, Charn, I see we still have quite a few questions, but I know we're running out of time, so we might want to do the raffle, and then we could maybe stay on a little bit and answer some more of those questions.
Sure. Let me just go ahead and put all the info for the random name generator real quick.
While you're doing that, I'll see if I can answer another question or two.
There's another one on here, Scott. What's the current NVIDIA AI chip availability, which has been in high demand and low availability, and Dell configuration options if offered? I'm not quite sure what the asker is asking here. Lots of NVIDIA GPUs can be used for AI workflows. Just depends on how heavy the workflow is and whether you're doing training or inference and what type of AI model you're using on it. So I'm not sure what to say there.
Yeah.
I unfortunately have a hard stop at 4. I'm going to need to drop, but I'll let you guys continue on.
All right, we'll take the rest of them then. Thank you, Don.
Thanks, Don.
Bye, fellas. Thank you, everybody, for attending. Hope the information was helpful.
All right, well, great. Thanks, Charn, and congratulations on the winner. And I can stay on for a couple more minutes if you guys want. We had a question about a 7670 with RTX 8000 graphics and recommended drivers. It looks like you're saying there are some reported issues with Service Pack 5. I don't know all the details on that. One thing I would say is you could just try the very latest driver for the A2000 graphics and see if that fixes the problem. And of course, check on the SolidWorks or the Dell website, because we'll have the one that was actually tested and certified. But a lot of times, if you're seeing some glitch, you can try updating to the latest and greatest driver, because normally, the fixes get added and carried through the newer drivers. So that would be my first recommendation. And then there's a question, is it worth it to, I guess, upgrade to an RTX A4000 to the new Ada Lovelace generation? I would say if you're doing design and simulation work, I don't think you're going to see a huge significant difference there unless your models are extremely large. You might see some benefits, but in general, if you're just doing design work and some simulation work, then I think you're probably, if you feel like your system is performing well, then I don't think you really need to upgrade, at least now. I mean, maybe sometime in the future if your models get larger.
Yeah, you don't really need to upgrade like every generation for it, especially between the Ampere and the Ada. They're just like a couple years apart at most. So if you have already an A4000, you should be good for a couple of years. Now, in regards to benchmarks for various workstations, like Scott said earlier, NVIDIA and Dell work closely with SolidWorks to make sure that everything is updated and working correctly. Even when they're releasing like newer versions of SolidWorks, they're going to test it a couple of hardware generations back as well, so that you know that you're not going to have any issues for it. Let's see. In regards to Xeon processors, with Xeon processors, they're good from a simulation standpoint because they offer more cores, but their clock speeds are usually not the highest because they're intended to run 24 hours a day, 7 days a week for it. So by the nature of their design for it, you're probably not going to be good for the modeling side of things for those in regards to that, because again, on the modeling side, it's single core, single threaded. So you want to make sure your turbo speeds are maximized there, and usually above a 3 gigahertz would definitely see a lot of benefit from it on the modeling side of things.
Yeah, and Charn, one little add-on to that is the new Xeon processors. So these are you may have heard them called Sapphire Rapids was the code name, or 4th generation. They have increased the clock speeds, the turbos on those. So they're not quite as fast as the cores, but they're pretty darn close.
Okay.
So but again, to your point, they're really not necessary. And I think a lot of core processors are still the ultimate sweet spot for SolidWorks. Now, again, as you're starting to get into 10, 12 or more cores, then you might want to start looking at the Xeon processors for simulation and other stuff.
No, it's good to know. And it's crazy how core count has gotten so high over the last few years, right? I mean, I still remember running like a 2-core Pentium PC.
Yeah.
All right. Unfortunately, Peter, there's no way to prevent Windows from upgrading. That's just the nature of the way they've integrated, starting with Windows 10. So unless you can find Windows 7 lying around, just remember though that Windows 7 is no longer supported on newer versions of SolidWorks.
Yeah, you can only delay it for so long, and then they force you. And I just was reading an article yesterday that Microsoft is really pushing everybody to move to Windows 11. So there's going to be a point where you can't avoid it.
Yeah. And Wes, your question on the DLSS. So the SolidWorks side of things, they're not going to utilize it as much for it. Just note that the new ray tracing cores and the tensor cores are helping with rotation and zooming in and out inside of the model inside of SolidWorks. Where DLSS does come into play is inside of Visualize, and there it's actually a toggle by using the denoiser tool that you can turn it on and off. And it's like what Don was talking about, where it basically analyzes it to help speed up your rendering time. What's actually happening is it analyzes 2 pixels side by side, and if it's the same color, tone, and all that stuff, it'll fuse them together and to help speed it up. That's how that whole process works for it. So you can turn that on and off. Just note that in Visualize, in order to have that capability, you do have to have 4 gigabytes of RAM or more as well. If you have anything less on your GPU RAM, so that VRAM that's associated with the GPU, then it's not going to be something that you can turn on.
Hey, and I'll answer one final question, then I've got to jump off, but Paul was asking about the AI, and then he made another comment about the H100 SKU. Yeah, that H100 product is offered on our server products. That's a server-related card, so you won't see that offered on a workstation, at least today. So you want to look at our like PowerEdge line of products, which are servers for the H100 product.
All right. Well, if there's no more questions, again, thank you everybody for attending this webinar. Again, hopefully you guys can attend any more webinars that we offer. Check out our website at GoEngineer.com for any additional information or questions that you have, or feel free to contact us as well.